We have previously talked about limits. So our limit notation was, you can see it here, we have the limit of f of x as x approaches c. This means that we are looking for the y value of the function as our x value gets closer and closer to c. Now we're going to talk a little bit about what are called one-sided limits. And we have two one-sided limits. We will have either the left limit or the right limit. The left limit is written like this. You'll notice that the c has a little negative sign. So this one we say is the limit of f of x as x approaches c from the left. Or sometimes instead of the left, we say the negative side. Negative, if you think about an x-y axis, on the x-axis, the negatives are on the left. So that's why we have a negative sign. You might be able to guess that the right limit is going to have a little positive sign. So the right limit is same exact idea, except instead of the negative sign, we are going to have x approaching c from the positive or from the right. So I think one-sided limits are best if you can see a few examples. So for this one, I gave you a graph. This is the function f of x. We want to evaluate several limits. The first one is the limit as x approaches 2 from the right-hand side. So keep in mind this is the right-hand limit, or the positive side limit. So for that one, if you look over where x equals 2, you'll notice that it approaches 2 from the right-hand side right here. And so the answer for that one is going to be my y value, which is 1. You'll notice that the limit does exist, the right-hand limit exists here. Actually, b also exists. So if you look at x equals 2, the limit from the left-hand side means that's going to be right here where it's going up towards this point. That actually is going to be equal to 4. So even though I have a hole in the graph there, it's not defined, I still have a limit there. Now, for part C, I have what's called a jump discontinuity. It jumps from 1 to 4. So this actually is not going to exist. So the limit as x approaches 2 does not exist. I'm going to write that as DNE. That's our shorthand way of writing it. Any teacher or professor in calculus will know what you mean if you write DNE, by the way. So the limit does not exist if the left and right-hand limits are different. I gave you another one, part E. I gave you the limit, or D and E, I gave you the limit as x approaches 0 from the right and the left. So for part D, from the right, it's going here. It is actually going to be equal to 0. From the left, it is also going to be equal to 0. By the way, this one should say F. Now, for part F, that is my overall limit. In this case, the limit actually does exist because it is equivalent on both sides. So this limit is equal to 0 also. For number 2, I actually would like you to see if you can pause and try to graph it and then try to do the problem on your own. So this is what the graph of this function looks like. It's a little strange. I think probably the easiest way to do this type of graph is to substitute in a few values. Like for example, when x is less than 2, you're going to want to substitute in values less than 2, but you're also going to want to substitute in values equal to 2. So like if I substitute in 0, 1, and 2, I know that when x is 0, y is -1. When x is 1, y is 1. And when x is 2, y is 3. That's how I got that this open circle was right there at 3. So I think that's a helpful thing to do for that type of graph. You can do the same thing for x minus 2. For 1, that's just a dot. So you'll notice that this graph has, there's a lot going on. There's a jump in it, there's an extra point. At 2, there are a ton of things going on. So let's work through this one step at a time. The first thing is, for A, we are looking for the limit as x approaches 2 from the negative side, or the left-hand side. Now, the easiest way to think about this is that as x approaches 2 from the negative side, that is going to be approaching from the places where x is less than 2. And if you look at the graph, you will notice that you go here, you get closer and closer to 3. Now, drawing a sketch of a graph is a little bit harder to do than actually doing it using algebra. So instead of just looking at the graph, I can actually use this portion of my piecewise function. So I know that when x is less than 2, that's going to be where the graph is approaching 2 from the left. So I'm going to plug in 2 for the x value in that portion of the function, and that actually gives me a limit of 3. For the next part, I am looking for the limit as x approaches 2 from the right-hand side, and you can see right here, you can see that it's actually at 0. Your other option is to think about the right as being when x is greater than 2. So we're going to use this portion of my piecewise function, and I'm going to use x minus 2, which gives me 2 minus 2. So that gives me a limit of 0. So my answer for that one is 0. So now you might be thinking, well, I used the 2x minus 1, I used the x minus 2, so for part C, I must be using that 0.1. And the answer, if you're wondering if that's the case, the answer to that is actually no. That is not going to be the limit. Now, if you're wondering what that actually, what this part does tell us, it does tell us that f of 2 is 1. That's a useful thing to know, but it doesn't say anything about the limit of the function. So you cannot actually put anything in about the limit of the function. The limit of the function is what we approach, the y value that we approach as our x approaches 2 from both sides. In that case, we're approaching 2 different values, so this is another one where the limit does not exist. So this is our limits existence theorem. It's a really important one if you take calculus. Usually any college calculus class that you take, this is one of the first things that you see. You tend to see a lot of theorems, and this one is the one that you get at the very beginning. So I might recommend maybe pause the video, write it down, try to understand it. I will explain it though. So basically what this theorem is saying is that if your left-hand limit, your left side limit, and your right side limit are equal, this is supposed to have a negative there, by the way. If those two things are equal, then they the limit exists and they also equal the limit. If they're not equal, the limit does not exist. So that's the basic idea behind it.